Hi, welcome to Digital Summit 2021. Thank you for joining us today. My name is Rahul Kumar, and I'm a software engineer at Aerospike. Here at Aerospike, I contribute to everything related to Spark. My plan for today is to spend like 35 to like 40 minutes speaking about how you can effectively use our Spark connector to power your AI ML use cases. And then save like, next like 15-20 minutes for any Q&A or any questions you might have about our connector. Yeah, so let's get started. Let me get to the slides and uh, all right, so let me get to the slides. All right, so let's start off by the few major challenges faced by the data science community today. Data scientists are looking to build highly accurate models in the shortest amount of time. Before I get there, let me have some timer so that stop. Okay, so let's start off by a few major challenges faced by the data science community today. Data scientists are looking to build highly accurate models as soon as possible. As you know, the training can take forever. For this Google I/O 2018 chart, accuracy of a model is a function of time. So that means like the longer you spend with the model, the more accurate it is. But it also implies that somehow we are lagging to put the models into production. That means like we want to accelerate the support process as soon as possible. So for examples like deep learning models, they can take like days and maybe weeks and sometimes months to like train them. And at the end of the day, we want these models to get trained as soon as possible and put them into production. Uh, so and like but unfortunately, the traditional HDD based systems are not suitable for training, which is very IO intensive due to the complex transformation involved during data preparations. Keep in mind that the trends and the patterns in the data keep changing rapidly. Hence, models need to be like retrained to address data rig and the shifting business needs. For a recent study, AI training workloads require almost like 6x DRAM and almost like 2 times more SSD. Uh, let me go to the next slide. Okay. So you can see, like, if you want to compare the speed and infrastructure and the scale, so like, if you want the fastest models, then basically you would like to keep the data into the memory, everything into the memory. But you can see like this, the cost corresponding to like in memory, all the in memory data systems could be like pretty high. So essentially, we want to have like some mixture of both, and this is where like Aerospike sounds pretty well. We provide like ability to keep everything into memory, or like we provide the persistent memory support, and or you could have a hybrid model where you store your database indices in DRAM and the data on SSDs, irrespective of the amount of data on an individual node. The data density per node per Aerospike is significantly higher than any other databases, and we preserve performance while minimizing the cluster size. Similarly, you can also choose all class for indexes and data. We work very closely with hardware vendors such as HPE and Intel to make sure that we leverage their bleeding edge storage innovations. Let me provide a blueprint for our AI/ML solutions. So basically, you might have the services provided by the like cloud providers, and essentially you might be using AWS, and on top of that, you might have a Docker, or you might have your Aerospike database deployed into either in the Docker or Kubernetes. And on top of that, you could use like our Aerospike Connect for Spark, and basically and combine it with different AI/ML libraries to build your applications on top of that. Uh, and To put some numbers, yeah, let me go to the next slide. So to put some numbers behind our words, one of our customers had deployed Aerospike and the Spark connector and seen extremely remarkable results. The use case was to create 360-degree profile for each user that visited the customer's digital asset. Our Spark connector has several features for achieving massive parallelism, scan by partitions, where we could independently go and do the read and writes from 4096 Aerospike partitions. We also do, excuse me, we also do predicate push downs. Essentially, that means like we only get the required amount of data, and we try to do most of the operations, whatever most of the operations on the DB side, and yeah. So and not just that. Let's say if you have a very large Spark cluster, in that case you could map those 4096 Aerospike partitions to 32K Aerospike partitions, and these numbers could be changed. So if you have a necessity where you have very huge Spark cluster as compared to Aerospike cluster, then please let us know, and we would like to try to increase that limit, and we would also like to understand your use case. Uh, so basically, like, this customer was using 33 Aerospike servers, and once they deployed our new Spark connectors, the time taken to complete their Spark job basically went from 12 hours to 2.4 hours. So essentially, you can think in the terms of with the TCO, and of course the latency. It was a very big win for them. So we certainly want you to give it a try, and give it a try to our Spark connectors. All right. So this could be one way where you might be where your this is one way where you could set your training pipeline. The data might be coming to a Spark database, and you could use our Spark connector where you pull the data from Aerospike using a Spark connector using Spark, and essentially you could do a bunch of things there. You could do the data exploration, you could do training, and you could do model validation. So basically, once you have a Spark connector, you could basically do all Spark related stuff using using our Aerospike database. And yeah, so and if you want to think of in the terms of a real-time system, the data might be coming from the external external services, either the data is coming from some the from the shopping carts, or it might be getting a string from vehicles, and all this data is coming to a Spike database, and basically you could use our connector for Kafka, and move all this data to Kafka, and from there you could run a streaming job using the Spark to do different kind of predictions, or a different kind of data validations, or basically any kind of data pipeline stuff. All right, so far, we have some understanding of where this Aerospike connector fits into your AI/ML pipeline. So let me go ahead and spend some time to build a simple application using a Jupyter Notebook. The application is simple, but I think it's it's a very clear overview that how you could use our Spark connector using in your day-to-day AI AI/ML data pipelines. All right, so let me switch to the Jupyter Notebook now, and basically yeah. So for this presentation, I am using Spark Connector 2.8.0 RC2 and Java 8, and I'm also using Apache Spark 2.4.0, and the ML models I'm building using Spark ML, and our 2.0 our Spark connector is built using Scala 2.11.12. You can do all those things using our 3.x connectors as well. We are at this point in time we are supporting both the connectors for Spark 2.x branch and the Spark 3.x branch. So yeah, but I would strongly suggest you to use our Spark 3.0 connector. We have noticed there is significant improvement in the speed and the latency, and the time it takes to run the big jobs. There is the Spark 3.x really shines there. So yeah, please go ahead and give it a shot. All right, So the first like the command you want to execute is like you want to tell Spark that hey, that these are the jars I'm gonna need to run this like run the following these are the jars I'm going to need in this application. So here I have specified that hey, this is the path to my Spark connector library, and like specified that what is URL of my Spark master. So if it is, if for me it is running locally, and for let's say if your master is somewhere else, then you would like to provide this the URL. And here in the jars, you could also have like you could also specify some other jars, external jars which you might be using. All right. So throughout this demonstration, throughout this demo, my plan is to like build a simple Spark application. And like basically what I'm gonna do is like get the data from get the data, read the data from my local file systems, and eventually like go through like data preparation step. Essentially, I'm gonna read the data, clean the data, and eventually like do some manipulation with the data, drop some like null rows, and basically like build a simple regression model and try to do inference using like some test data set. And during the course, I would also, and when we go through all this, what I would try to do is like take you, I will take you through like our query models, how our query gets executed, and particularly try to draw a clear distinction between the scan, the queries, the batch gate queries, like or the queries which involve like primary keys, or and the queries which requires the scan of the nodes. So yeah, let's get started. So in this like the second the second command is like what I've done here is like basically imported done some import statements, and like specified some variables. I have specified where my Aerospike server is, and like where my feature file is. So one key important part about the feature file is like if you're running as if now, excuse me, from 2.8.0 onwards and Spark 3.1.0 onwards, you might not have to provide a feature file on the application side if your Aerospike server is configured with it. In case if it is not, then like there are multiple ways to do it. So maybe you could check out our documentation on how you can specify feature files in different settings. So in my case, my feature file is sitting on the local machine. My Spark is on my local machine. And all right, so once we have and I go ahead and like set all these configurations, and the reason I'm doing it here is like let's say if I'm going to run like multiple Spark jobs, and that means like I don't want to set this like feature set these flags over and over, and if I set it into the conf, it's going to get propagated into all the like downstream batch jobs. Yeah. So yeah, so I took all this like I constructed this configuration object and created a Spark session out of it, and now I'm going to use this Spark session like into all our Spark jobs. That means like all these set variables will be available to me downstream. All right, for this demo, I'm using this natality data set. Essentially, what it does, like provide different kind of features, and like we use this data to predict the weight of a baby at their birth time. So so this whole data set is like I think like 22, 23 gigs for this demonstration. Since I'm running everything locally, what I've done is like taken almost like 500K records out of it, and like put it into my local file system, and I'm going to use that like 500K records for doing this demo. So this is the part two, and yeah, this is a CSV file basically. Here, this is a part to my local file system where this data lies, and essentially what I'm doing here is like, let me just say that. So here it's pretty simple. What we're doing is like telling Spark that, hey, read this CSV file for me where the data lies at this location, and header is provided into data. And once that is done, what I try to do is like print the schema of the like the loaded data frame. So
All right. So I print the schema, and I want you to like carefully take a look at this. So you can see like, I think we have like almost 30 or so, like almost maybe like 30 or so like columns, and all of them has this string type, right? So let's say down the stream, like if I want to build like some kind of regression model, I would like to have some kind of numerical features, right? Which makes more sense and like slightly more easier to understand. So I'm gonna be doing those transformations later in the later stages. All right, so we have loaded the data, and we can see that data got loaded perfectly, and like we can see the schema that all the fields got inferred as like string type. All right, so now I'm going to start with the data cleansing part. So what I'm going to do is like take this big data frame and eventually like slice out, keep only the columns which we are going to be using during our like model building process. Like I'm going to drop like some data points which I think like either they are incomplete, and so they might have null. So I'm going to just drop those things, and I'm also going to rename some columns and basically manipulate the data types, and like now I'm going to add a new column as well. So here, what I've done here is like, I have just specified it. This is just a string which says like, take this string and like, basically split it and like, convert them into columns. So once I have this into column, what I'm going to do is like, use this array of columns to create a smaller subset of data frame from the bigger data frame, whatever we just loaded right now. And after that, I just print it. So you would see like now we have like much lesser number of like columns. So we have the weight pounds, mother's age, father's age, gestation weeks, and weight gain pounds, and abcat underscore 5 minimum. So this is what we want to predict using these like the features. Excuse me. So yeah, and still you can see like all these things are still straight. Uh, And there is one more thing I would like you to notice here. So you see, like there are a bunch of rows which like some null values, and it's like since we printed like only 10 rows, it is quite possible that there are a lot more nodes. So either we need to have a strategy how we are gonna like how we're gonna handle these nodes. Either we're gonna drop it or we're gonna replace it with some other value. And this also means like when you're running a prediction model of on like some production data systems, then essentially you would also like to have a strategy. Or like if the data coming in has some missing data point, how you're gonna handle it? Either you're gonna not like do any prediction, or you're gonna like put some value into it. So yeah, that's one thing you would have to handle based on your application. So what I have done here for my convenience, I have decided that I'm going to drop the rows which have any nulls. So I end up dropping them, and essentially I just printed like two rows. So far everything looks good to me, and now what I have done here is like, okay, I have like bunch of columns and I want to rename these columns. So the one reason is like Aerospike does not allow you to have a bin name to have a more than 14 characters. So the bin name is somehow synonymous to columns in Spark. So in Spark world, we call it columns, and the bin name in Aerospike, we call it bin names, bins. So basically, at times I might be using bin names and like columns synonymous. So if I'm saying bin names, then probably I'm talking in the Spark world, and columns I'm mostly like talking into the bin names. I'm talking to Aerospike world, and the columns I'm talking into the Spark world. So what I'm telling you here that this is the map of this is the map of old feature name to new feature name. So like look at this entry. So it says like if you have weight gain pounds, change into weight underscore gain underscore LP. So we take the previously DF without null, and we apply this transformation in it, and we say like take all the columns of df out without null, and like take so df without null dot columns gives you a string array of strings of the column names. construct into column and like rename it. All right. So we have renamed these like columns of our data frame, and you can see here like particularly like weight underscore gain underscore LB. So earlier it used to be weight underscore gain underscore pounds. You can see it here. Now it got changed to weight underscore gain underscore LB, and the transformation is here. So yeah, so essentially we have renamed our columns. Now what we want to do is like to convert into format, which is more suitable for our modeling purposes. So what I've decided that I'm going to convert weight underscore pounds to double and rest of them as to int, and apply this transformation. And I have created a very simple UDF. Ideally, UDFs are not the best way to do the transformation because the catalyst optimizer cannot see through them. And anytime when you do the UDF, that means like, they do not get pushed out to the database. So you might want to like, be careful around it. So I have done these conversations and conversions, and essentially like you look at the type, you look at the schema for this data frame, and here you could see that everything has changed into the way we intended it to. And now this field has the type as double, and all other fields have like as integer. And there is one more thing I've done here. I've introduced a new column here, IDE, and using like monotonically increasing ID. And so this function as such is what it does, like creates a monotonically increasing long for every column entry named ID. However, it is not stable. That means like next time you run it, the same entry might get a different value for ID. So you might want to be careful about it. And I'm going to use this column to do like do some demonstrate some like creating abilities of Aerospike connector, just for like demonstration purposes. And I'm not going to use it during the modeling process. All right, so we print the schema for this data frame now. Now we have like one more column ID, and we have changed the types of everything. So double and all these fields are integer, and the new field we just introduced, the monotonically increasing ID, has the long type. Correct. So so far, I think the data is prepared. We have dropped the nulls. We have transformed them. We have renamed them. We have cleaned them. So all set, and we have added a new column as well. So what I'm going to do is like write all this data to our Aerospike database, and from there we could like explore how we could read data from database into like different ways. All right, so we take this data frame. This is typecasted DF with ID, and write it to Aerospike. We specify format here, and format for Aerospike is like Aerospike. And we say that write to this set, which is like train underscore sample. So you can draw analogous. You can think of Aerospike set as a sort of table into a standard databases or the SQL databases. And we say that use this column ID to create primary keys for Aerospike. So so Aerospike is in simple terms is a key value data store. So essentially, you need to provide some way to construct key, and that's how for this data frame we are saying that the contents of this column should be used to create a primary key. We could have used some other column as well, like mother's age or father's age, but that means like we will be overriding the data, because there would be many entries where the mother's age is like 40 or like something like that. Or you could do like a bunch of things. You could do like do the transformations, combine multiple columns, create one entry. Excuse me. So basically, you can do anyway. You can handle it in any way you wish. All right. So now we have written the data to Aerospike, and what we want to do is, excuse me. So now we have written the data to Aerospike, and now we want to read the data from the Aerospike. And one more thing I want to mention here, that there are a bunch of options we have not explicitly provided here, like the name, seed host, and all those things. But all those things are getting propagated because we set it into our Spark session configurations on the top, like I think here. Uh, Here, right? We have set all these things. I'm going to talk about this Aerospike partition factory. It's a very important like flag, and like we have also set here the namespace. So namespace is sort of again equivalent to in Aerospike. In Aerospike, namespace is equivalent to a database. Yeah. So all right. So let's go back to the place. All right. So what I'm gonna. So there is one more thing. Yeah, like Aerospike is a schemaless, and Spark means like you need to have a strict schema. So after the schema is decided upon, data within the bins must honor the type. So essentially, like when I'm reading the data from the database, and if it has the mixed types, then Spark would not allow it. So essentially, it might throw errors, but we could handle it. And and I'm going to talk about it later. And to infer the schema, there are two ways you could run Spark. Spark jobs on any third-party databases. Like either you gotta provide a schema, or like the connector, whichever the connector you are using for whatever the specific database is, they have to have some way to infer the schema of the data. And so to infer the schema, what we do is sample a bunch of records, and this field could be configured using this flag Aerospike schema.scan. You could provide a large number of values, but you want to make sure that this value is not too large. Because what we're going to do is sample all these records, and get all those records to your master node, and eventually it might run out of memory. So it should not be very large, but I think it could take all the way up to integer dot max value. But however, so yeah, this is one way. This is how we go ahead and infer the schema. But inferring is like I said, it's a sampling. So that means if I next time when I go and sample the records, I might get 100 different records where there are 10 bins set, and 10 bins have a different type. So essentially, the schema is schema detection is hold up, let me put it to charge. Looks like my laptop is running short of power. All right. Yeah, I was talking about that the schema detection is non-deterministic. So ideally, we would like you to provide a schema. Particularly, it gets very important when you are using complex data types. Like you have the list of lists, and within that, it's a very nested structure and all those. And in those cases, we cannot infer the schema properly. So in the production systems, we strongly suggest you to use to provide a schema. All right, so here we are trying to load the data. We are saying that load the data from this specific set and just print the schema. So if you notice here clearly, how the data we wrote to database did not have all these columns. So essentially, these are the additional metadata which we get it. So and also I wanted to notice the type of the the known columns. So weight pounds is double, which is good, but there are all those things we wrote as long int, but they are being inferred as long. So if you want very precise the type, then we strongly suggest you to provide a schema. And however, when you provide a schema, everything is okay. Here we have said that this is the schema we wrote into database, and we use this to load from the Aerospike, and we said that to read use this set 10_sample to load our data frame. And you can see here everything looks good, and the types are good the way we want it, and yeah. And So again, it's worth spending some time on the collection data types. Essentially, this could be list of lists or list of maps within the list. So basically anything. So, so for this demonstration, what I have done is like, created a sample data set. You can see this, like, it's a pretty nested data structure. It's like sort of creating a profile for a person. The person has a first name and the last name. Excuse me. And they may have like a bunch of aliases, which they might have assumed during their life. And they have SSN, and they have like multiple home addresses. They have work history, past work history. So essentially pretty rich and nested structure if you can think of. And what I've done here is like, I constructed some random data using this schema, and like written into a database. And I'm telling them that, hey, to construct the key, use this name.first. And so essentially it's saying like, anytime when I see the name, like here, I'm going to use the first name to construct the primary key. So that means like, if you, let's say if you have a nested structure, they can use some nested value into the from the data to create a primary key. Yeah. So yeah, I mean, like, look at the documentation. We have a much clear, explanation how to use it and the restrictions around it. So yeah, so now what I want to do is like, try to read this complex data from the Aerospike when we provide our schema. All right, so we provide a schema, and like, if you can see it, like, so we have provided our schema. We are saying that go ahead and read the data from this specific set, and essentially, and we have printed like a bunch of columns. You see, like everything looks good, right? Yeah, it's not printed wholly, but everything looks good. And now we try to do the same thing when we do not provide the schema in this complex data types. And so you see here, like the schema inference, it loaded the data, good, and excuse me, it loaded the data, and again it has some additional metadata. That's fine. And if you see it here, like these things are pretty like, it's not the way it should have been. Like the way we written it was like, it was, I think, array of some list of list, and it's like here internally it is assuming array of map, and somehow, and then it tried to later cast this data using this schema, and it just failed because that's not how they structure the data we wrote it into. So so if you have like this kind of nested and complex data structure, then I strongly suggest you to provide schema. And again, so it is quite possible you might have the applications, you might have the multiple applications writing into the same bins, and in that case, it's like you have the multiple types of data getting written into the bins. To handle those cases, you could use our flexible schema inference. What it does, like if it is set to true, which is by default, that means like if there is a mismatch between the schema provided by the user and the data fetched from the database, then what we do is like set it silent to null. Then that implies that there is no way to create a distinction between the data which is really null and the data which is set to null because of the type mismatch. And if it is set to false, I mean, when this flag is set to false, we just error out. So, so yeah, let me give a very quick example of that. So here is the same data which we wrote into our database. So you would notice here that I have the ID field, which was whose type was long, and we have said that we have given a wrong schema. We said that ID is of a string type, and we try to read this data, and we say it is flexible. That schema aerospike.schema.flexible is true. That means like anytime when you see there is a mismatch of type, handle it gracefully. So yeah, here you could see it here that it's like null, right? Instead of like the erroring out, the connector has set it to null. It's the same thing here. What I have done here is like set it that I don't want any schema, flexible schema, and you could see like there is a type mismatch exception. All right. So we have introduced a new feature, sampling from Aerospike database, and essentially what it does is like it allows you to like let's say there are times when you want to sample like X number of records to either data exploration or model building. In that case, you could just use this feature, and essentially this is like the interplay of Aerospike partition factor and Aerospike sample size. So yeah, now the time I should spend some time like talking about the Aerospike partition factor. Aerospike partition factor just takes the value between 0 to 15, and what it does, like it constructs the number of spark partitions using these values. So essentially that means like the value is set to 0. That means like you have 2 raised to the power 0 equals to like 1. There will be just one spark partition. And if you have like 2 raised to the power 15, that means like you have 2 raised to the power 15 spark partitions. I think that is like almost 32K partitions. And so so let's say like for this example, let's say the sample size is 101, and we in this demonstration we use like multiple different partition factor. And so what happens internally is that we take this like sample size, and depending on the Aerospike partition factor you have specified, we try to compute that how many number of records each of them should get it, right? So in that case, what we do is like like there is a set number of records which is each partitions is gonna get, and we try to divide it like evenly. So it is quite possible some of them might have like if the number of partition is large, some of them like we might end up like getting large like slightly more number of records than you ask for. So yeah, look at this example here. The partition factor is 2, and we are trying to get like 101 records, and here partition factor is 6. And the count, like excuse me. All right. So I try to do here count on these like fixed data frame, and you see like we end up getting like 104 and 128. However, if you really want like the X number of records, then like a very fixed number of records, then you could apply limit spark limit on top of that, and in that case you get like 101 records. All right, let me quickly touch base upon like queries, how we do queries. So in the beginning, as I mentioned, like Spark Connected does execute queries in 2 ways. Anytime when we see a query, we try to convert into a way where we only have to do the primary key lookup. And if we cannot do the primary key lookup, we try to do a scan of every nodes to get the data. All right. So here, like we are doing the we are querying on the on the same set which we wrote in the database, and here we are saying that the value of the primary key is 829. So and like the key type is int. So essentially, when you don't provide a schema, what we do is like it's a sort of hint to the connector that the primary key type was constructed using int, and primary key type was constructed as unt. So essentially, like since you are doing the schema inference, make sure that you set it as int when you are trying to do the schema inference. And after that, we do the batch gates. So batch gate is like sort of primary key lookup, does not involve any scan. And here we are we are setting is this like column name underscore key. So underscore key is a way to indicate to the connector that okay, I'm doing a primary key call. All right, same thing. We can do the the OR between different kind of primary key, and we can get the data. So here again, you could see like the column underscore key, and like it has multiple values, range of values from here, and a range of values from here, and we try to display like the first number of records. All right, looks good, and so there are times we cannot convert the queries queries to the primary key query. So essentially, even if the query has underscore key, and if it has an OR operation with another column, that means like we cannot convert into a primary key lookup, because this query gets split into 2 parts, and the one part might be a primary key call, and one part might be the scan, and essentially we cannot combine them together. That means like we have to scan the whole nodes to the Aerospike nodes to get the data. So in this case, like if you say that we also say that like we indicated the column and underscore key is in like this sort of these values, and like there is some column or the bin which has mother underscore eight greater than 40. So since there is OR operator, that means we cannot convert it. However, we can do the OR over like two primary key queries, but anytime when there is OR between primary key and like bin, then in that case it's slightly different. Primary or between primary keys and primary keys is still primary key query, or between primary keys and like bins is not a primary key query. All right. So there's one thing I really want to touch base upon is like the difference between the time the batch gates and batch gates and the scan queries. So what I've done here is like constructed almost like 50K records. Yeah, this the reason I introduced the ID field, and so that we can do like primary key queries, because we know there are like this the primary key ranges from 1 to 50K, like 500K, because that's what the number of the training sample records. All right. So you can see here, like so I ran the query, pretty much similar query, and like here I say like the primary key is within that range, and here I say that bins are within that range, and essentially you see like and if you try to measure it, it's a very like very simple query here, but imagine like you have like billions of records in the database, and like the much large amount of resources, and you have like a lot more Spark partitions than I have into my local setup, then you would have very huge difference here, very huge difference between the batch gate and the scan query. All right. So anytime when you have the ability to write the primary key query versus scan queries, I would suggest you to take a first step, try to see if you can run it as primary key queries. All right. So now what I'm gonna do is like build a simple regressive model using the data we have, and like create do some prediction. Take a look at what is the distribution of our training data set look like, and like and evaluate the model what we just constructed. It could be done either in the batch fashion or the streaming fashion. We have quite a bit of extensive documentation. Please take a look at them, where we talk about how you can do into the streaming job setup, where the data is coming flowing through external system, going to Kafka, and essentially where from there you could use a Spark stream to run your predictions. All right. So what we do here is like load the data, and once we load the data, I'm dropping the ID. Remember, this is dropping the ID column. This was the column we added for demonstration of primary key queries, so we should drop it. We should not involve into any kind of modeling process. All right, and Spark requires you to provide a label column, which is used to identify that, okay, this is the Y, if you think in the terms of a regressive model. So what I've done here is like taken this data frame and renamed this weight underscore pound to label. Remember, we wanted to predict the weight of the baby after their like birth. All right, and after that, I took all the columns of this data frame and eventually removed label. And basically like created the set of I'm specifying that these are the features, these are the columns from the data frame which are to be used as features. All right, and after that created a vector assembler, and from there created features, applied the transformations. And here what I'm doing here is like okay, whatever the data I have like history database, let's split them into like 80-20%. 80-20 scheme, and use that to train and test onto our corpus. All right, and before we go into any modeling aspect, there's one very important aspect here is to analyze what of the data we just we are using for the training. So you can see here is like let's say if you wanted to do like null, you wanted to replace null value into the incoming data, which might have the null value into a record. In that case, let's say you might choose to do fill it with medium, fill it with the average. But let's consider one of these fields, like the mother's age. Like here, the mom's age. Excuse me. Mother's age mother's age lies between like 10 and 54, and you might like try to take an average or something, but see like how much it varies. So in that case, you want to be careful how the data distribution looks like and how you are using into like filling the null values. All right, so what I've done here is like created the linear regression model, applied trained the model on top of that, and essentially after that like try to do a test over like our left our leftover data, like 20% of the data, and like just like let's print the sample prediction. And after do the transformation of this data, you can see like there's a new column here with the prediction. And we were trying to predict this column, and like these are the corresponding prediction by the model, and these are the true values basically. And we print it here, and you can see like what is the difference between them. And like done a very simple error evaluation here, like printed the RMSE, and you can see like the RMSE is like 1.06 over our test data set. So essentially, you can reach like you can build like very rich models. So yeah, that's all about. I had it for like how you can use our Spark connector effectively. This is the link to our documentation. Please take a look at it, and we have much clearer and much extensive, I would say, like documentation there. And we have recently revamped it, and hopefully you find it helpful. And thank you for joining me today. And please just hang around for a bit so that if you have any question, I would love to answer them. Thank you very much, and have a great day.
Hello, everyone. Thanks for joining our session. I hope you enjoyed it. Thanks, Rahul, for such a wonderful presentation. I really enjoyed it. My name is Kiran Maddy. I'm the product manager for the Aerospike product line, and I'm joined by Joe Martin, who heads up the engineering for Aerospike Connect. We have received a lot of questions, actually. And Rahul, I'll bring it up and let's go through it. So the first question that we have received is, does the connector support Spark streaming?
Yes, connector supports Spark streaming. So what you can do is like if you notice into one of our slides that you could have a Kafka connector and let the data flow from Aerospike database to the Kafka, and you can use the Spark streaming from there. Yeah.
And we can write in Aerospike in a streaming fashion as well, right? Rahul?
Yeah, basically you can do the read operations when the data comes from the Aerospike, and you can, once you have the data processed and everything, you can write the data back to the Aerospike into some other namespace. So basically you can have the whole complete loop down here. So yeah, you can do everything, every streaming operations using this Spark connector.
Yeah, streaming in direct, it doesn't have to originate from Aerospike. It can be from any source to Aerospike or from Aerospike at all. It can be one direction too.
Yes, absolutely. That's correct.
And just to add to that, we support structured Spark streaming, which provides very low latency. Yeah. Moving on to the next question, Rahul, how to deploy the connector in Kubernetes or Docker?
So essentially, Spark 3 supports the Kubernetes and Docker natively. So basically, you can deploy all those things using Spark 3, and that's not be a problem at all.
Right. So we provide shaded jars that they can use to create their Uber application jars that they can submit to the Spark cluster using Spark Submit. And as you mentioned, Rahul, Spark 3.0 has first-class support for Kubernetes. So it takes care of deploying it across the Spark cluster.
Right.
Right. All right. Moving on to the next one. What languages does the Spark connector support?
So far, we have been testing with the Scala, Python, and Java. But since the Spark works with other languages as well, like R, which we haven't been testing, but I think it should work out of the box with other languages as well. All you need is our Spark connector, and you should use the way you have been using with any other language. So as long as Spark supports certain language, it should work. But there are some functionalities which are only available on the JVM. Like our array join functionality. So basically, if you want to use this specific functionality, you gotta stick to either Java or Scala.
But that is a limitation of Spark. I mean, that is Spark with Python only supports data frame, not data sets. That's the limitation. It's just with the language. Whatever the limitations are, those are the limitations.
Yes, thank you for clarifying. Yeah, thank you for adding that.
All right. Thanks, Joe and Rahul. Moving on to the next one. Can we load Aerospike data into GPUs using the Spark connector?
Oh yes, again, Spark 3 has like the support for the GPU, so everything should work out of the box. We are in the middle of like testing all those things into in our internal setup, but it should work out of the box.
Right. So as Rahul mentioned, Spark 3.0 has native support for GPUs. So GPUs are a schedulable resource in Spark 3. They have support for something called as Spark Rapids that lets you run. I mean, we haven't tested it yet, but with its support, we can run the Spark connector on the GPUs, something that's on our short-term roadmap. Moving on to the last question, Rahul, do we support predicate pushdowns?
Yes, we support different kind of predicate pushdowns. Basically, if you look at like all the filters which Spark exposes, we support like all those filters, and we can push down. We try to push down as much as we can to the database. We are also working on some functionality where you might be able to do like different kind of pushdowns through which is supported only by the Aerospike, and it might not be part of the Spark support. So we can you might be able to do those things in future as well.
And that's all we have for the questions. Unless somebody wants to ask any questions, put that in the chat window, please. I think that's it. Thanks, Joe and Rahul. I hope you folks enjoyed this session, and please reach out to us if you have any questions. Have a wonderful day. Thank you.
Thank you for joining us. Bye-bye.
Thank you all.